Yeah. The last day of new stuff. Then we just review. I know. Okay, so before we start the notes, there are a couple things I want to talk to you guys about. First of all, don't forget to turn in this paper before you leave so I don't have to take off any points for being late. So make sure I get that today. The other thing is tomorrow. Listen. Tomorrow I'm going to have to be gone. I have to take my mom to the doctor. She had a fall earlier this week and she's injured and all that. So I got to take off tomorrow to do that. So I'm going to explain to you now what you're going to work on tomorrow so that it doesn't get confusing. Okay, because the sub may not be able to answer your questions. So there are a few things. I'm going to give you some options. You will have your packet for questions number 2. Okay, so you can choose to use your time in class tomorrow to work on those. Okay, so for your second set of multiple choice, you can work on them during class. The answer key is already up on Canvas, so you can input them and check your answers and all that just like you did with the first set. Okay, so that's option 1. The other thing is you're going to get a handout that looks like this. It has all of the different tests that we've done. And it's blank on the inside. So you'll be able to just create this foldable as a way to organize all of the tests into one place. Okay? So on the inside, you get to write whatever you need to remember about each one. So I could give you notes on it, but it may not be what you need to remember because it may be different for each person. So this is going to be an option. You can spend time tomorrow filling this out. Okay? The third thing, this is one that I have a feeling some people have forgot about because this is something I've been leaving to you to do on your own. But remember these things? So you should have first semester done because I've already taken grade on those. But second semester, not so sure that all these are done. These are all posted on Drive. You're supposed to just be doing them on your own as we went along. Not so sure about that. Here's the thing. Now listen closely to this because you're going to go, I didn't hear you say that. Yes, you did. Or you were choosing to ignore me. This is due next Tuesday. I will take a grade on this while you're taking your test 6. I will be checking these. So, tomorrow, if you want to use your time in class to work on this, that is another option. So each card is on Drive under the flip cards file. You can find each one of these, and I also took a picture of all of them put together so you know the order to fit them in. Okay? So all of that is on Drive. You can work on that tomorrow in class if you want. So I've given you 3 options for tomorrow. That should be plenty to keep you busy. So please don't just sit and talk. Do your work so you don't have to spend your weekend doing it. Any questions on tomorrow, what you're expected to do? Okay. Okay. So our last set of new stuff, which is sort of new but not a whole lot of new. This is our computer output. So this is whenever we put data into a computer, oftentimes in a real life setting or especially like in a college class setting, you use a computer lab to analyze your data rather than just doing it all on a calculator. Okay, because you're dealing with larger data sets, things like that. So you would use a computer. So this is an example of some computer output from a test. Okay. So let's review what we have here. We see up here the second line says dependent variable is math test. That is our y variable. Okay. So when we're writing a linear regression equation, we have to put it in context, so this would be what you write in place of y. So you'd write math test with a hat over it equals whatever comes next. Okay. When we go on down here, this anxiety level, that's our x variable. So that's our x and y variables. Whenever you write a linear regression equation, it should always be with those words in place of x and y. Some of the things we talked about in our warm-up, the r squared, That gives it to you right here. We never use the adjusted. That one is one we do not use in this class. S, that's our standard deviation. Degrees of freedom, you'll notice this is our sample size minus 2. So our degrees of freedom here is always minus 2. And then on down here we have our constant with the coefficient of that. What is the coefficient of constant? What is the other name for that? Say it again. Y-intercept. I heard somebody over here. So what's the coefficient of the x variable called? The slope. So that's our y-intercept and our slope. These are all things that we talked about earlier in the year that you should remember from there. Any questions on that part? Okay. So now we're going to be looking at doing some inference. We're going to be looking at confidence intervals or hypothesis tests regarding this slope. So, as with all of our other tests, we have some conditions that need to be met. So the first condition has been a condition for every single test we've ever done. What is it? Randomization. Very good. So we want randomization. So that means either the sample was randomly selected or treatments were randomly assigned. One of those things needs to happen. The other thing, since we're looking at slope of a line, we need it to be linear. Okay? So that's our other thing we check is linearity. So we have two different ways that we can check this. The first one is we can make a scatter plot of the data. And sometimes they will have one provided and you just have to comment on it. But if you're making one, make sure you write it on your paper. Don't just say, I made a scatter plot and this is what I saw. You have to show it. Okay? So what we're looking for here is, does it appear linear? The other thing we can check is the residual plot. And there we want to see, is it randomly scattered? So you just need to check one of those two, but whichever one you do, there needs to be one of these plots on your table or on your paper. You need to also identify which one it is because these look very similar. If all you see is this sketch, you're not going to know which one it is. And it's very different results that you're looking for, so you want to make sure you identify which one you've drawn and what you're looking for in that plot. The degrees of freedom, we've already said, is n minus 2. We do that because this is bivariate data. There are two variables. The t-test that we did before was one variable, so we subtracted 1. Now we have two variables, so we subtract 2. Then, for a confidence interval, the name of the procedure is a t-interval for slope. So if you remember back when we first started doing t-intervals, I said you have to write 4 means because there are other types of t-intervals. Now you're seeing what I'm talking about. So now it's for slope. You're using the same thing on your calculator to get it if you're doing one on your calculator, but now it's for slope instead of for means. For our math, let's mark through that part. That was supposed to be deleted and I didn't get it done, sorry. So our math equation is going to be b plus or minus, because remember when we did the slope on our calculator, when we found the regression equation, we chose ln reg a plus bx. The b is your slope. So that's your slope that we found in our data. And then the t critical value times the standard deviation, but here we call it SE, so for standard error of the slope. So SE with a subscript of B. So most of this we can just get from our computer output. So when we look up here at the top, we see, we said the coefficient of x, this is our slope, so this is the value of b. And then you'll see the next column over says SE coefficient, so that's standard error for each coefficient. So this is the standard error of the y-intercept, this is the standard error of the slope. So this number right here is our SE of b. So we're just going to take those two values and put them into our equation down here. So this t critical value we find from the table. Okay. Now we need to find the critical value, which means we need to know degrees of freedom. So what did it say up in the computer output for our degrees of freedom? Right. So it's 22 degrees of freedom. So to get our t critical value, just use our t table. We go to 22 degrees of freedom. We're going to do 95% confidence, 2.074. So that's all the values put into the formula. So to get the confidence interval, I just do the negative, so I do the slope minus this, and then I do the slope plus. And that gives me the two values. So these are the values I want to use for my confidence interval. Always put smaller number first, bigger number last. So we're going to have negative 7.7047 and then negative 1.2753. So that's my confidence interval. Any questions on that part? For hypothesis test, we're going to do a t-test portion of it. So just as we saw in previous tests that we've done, we use, like for means, we use x bar for the sample mean, and we use mu for the population mean. So we use English letters for sample, Greek letters for population. So we use the English letter B for our sample slope. For our population slope, we're going to use the Greek letter for B, which is beta. So it looks like a capital B, but it has a tail on it. So our null hypothesis is always an equal sign. Typically, it's 0. But there have been cases where they've asked us to test for something else. I talked to you guys last week, I think it was, about question 6 and how it's going to be something different. I have seen a question 6 where they asked you to test to see if the slope is 1. Okay? So, if they ask you to test for something else, just put it in and do everything else as normal and you're fine. Our alternative is going to be some sort of inequality, less than, greater than, or not equal. So if they ask you to see, is the association a positive association, you would say beta is greater than 0. If they ask if this is a negative association, you would say beta is less than 0. If they just ask to test if there is an association, which is more common, then it's just not equal 0. Beta true slope. equation for the relationship between, in this, the x variable and y variable. So here the x variable is anxiety level. And the y variable was math test. For our do the math, this is going to look very similar to what we've looked at before. When we were doing a t-test for means, we had x bar minus mu over the standard deviation. Now we're going to have the sample slope, so b, minus the population slope, which is going to be beta, over the standard error of b. So it's just like what we did before. The value from our sample minus the population value over standard deviation. So for this in particular, the b that we had up above was negative 4.49. Our beta, we're always going to use what was in HO, because this is what we are believing is true until we can prove otherwise. So beta is 0 over our standard error for b, which was 1.55. So then, since we're subtracting 0, basically we're doing negative 4.49 divided by 1.55. So I get negative 2.8968. Now, if you look back up to your computer output, you'll notice this value right here. It's the t value for the test for slope. Okay? So, this is the t-test statistic for slope. So it's providing that for you. So what do you think is going to be our p-value for this test? There you go. So that's our p-value right here. So we can use that to compare to alpha and make a decision. You feeling okay with this? That's so good. Okay, now let's look at the other side. So here are some examples. A lot of times you see this type of question on multiple choice. Okay, so we're going to look at a few of these together. So here we're looking